Hi, today we are gonna explain on adapter pattern presented by Geetanjali, Manoj and Alexandria. In this we are gonna explain about all these contents, and coming to the introduction part, adapter design pattern is a structural pattern that acts as a bridge between two compatible interfaces, allowing them to work together. It is especially useful for integrating legacy code or third party libraries into a system. So, the adapter design allows otherwise incompatible classes to work together by converting the interface of one class into an interface expected by the clients. Coming to when the adapter patterns are used. An adapter pattern can be used when the wrapper are particularly interface and must support the polymorphic behavior. A decorator pattern makes it possible to add or alter behavior of an interface at runtime. So we have four steps that are adapter, decorator, delegation, and facade. In adapter, we convert interface to another that it matches what the client is expecting. In a decorator, dynamically adds responsibility to the interface by wrapping the original code. And in delegation, composition over inheritance. Facade provides a simplified interface. And coming to the next part, the intents and the key features of this adapt pattern. Adapt patterns are used in an existing class rather than in modify for reuse, and they are easy to convert interface of a useful class into an another interface clients expect. It is also known as a wrapper design pattern. It wraps existing functionality of an adaptee with an adapter's inherited interface. Now, one of our teammate is going to explain the next slide. Thank you.
Now I'll be explaining when we should start, when we use the adapter pattern. We use an adapter pattern when we already have existing classes, but their interfaces don't match what we are currently need. Instead of rewriting or modifying those existing classes, we use an adapter class to provide a common and expected interface. Next, we use an adapter when we want a reusable class that can work with external software or legacy code. We also use an object adapter when we have multiple different subclasses or adaptees, all inheriting from the same parent class. In this case, one adapter can work with all of them. Finally, we must use an object adapter when the adaptee class is abstract. Overall, we choose the adapter pattern when we want compatibility without modifying the existing code. And next, let's look at the main participants involved in the adapter pattern. The adapter pattern is a structural pattern that acts as a bridge between two incompatible interfaces. It allows them to work together even though their methods. The first participant in the client which expects to call. Oh, 1 second. Uh, the first participant is a client which expects to call a specific interface, and the second participant is the target which defines the interface that the client expects. The third participant is the adaptee, which has the actual useful functionality but in different format. This pattern is especially helpful when integrating the legacy systems or the third-party libraries into a new application that we're developing on our systems. And coming to the next slide, we have an UML class diagram. Now I'll explain the UML class diagram for the adapter pattern that we chose. Here, the client wants to use the target interface and it expects to call a method named request. However, the adaptee already contains the functionality we need, but it provides it through a different method called specific request. Because these interfaces don't match, the client cannot use the adapter directly. So the adapter all solves this problem by like the adapter implements the request method from the target interface, and inside this method it calls the specific operation method of adapter. This way the client can continue using the interface it expects while still benefiting from the functionality provided by the adapter without changing any existing code or the legacy code. This UML diagram clearly shows how the adapter acts as a bridge between the client and the adaptee like a class. Yep. And my friend Alejandria will take over.
Okay, here we have our two patterns, the class adapter and the object adapter. For the class adapter, the class inherits from both the target interface and the adaptee. The programming languages that allow multiple inheritance, like C++, are most likely used in this technique. However, languages in Java and C++ which do not support multiple inheritance, this approach is less frequently used. For the object adapter, it employs composition instead of inheritance. In this implementation, the adapter holds an instance of the adaptee and implements the target interface. With this approach, it is more flexible as it allows a single adapter to work with multiple adaptees and does not require the complexities of inheritance. The object adapter is widely used in languages like Java and C++. Here is an example of a adapter design pattern. It is a scenario where we have an existing system that uses a legacy printer class with a method named print document. And here we want to adapt in a new system that expects a printer interface with a method named print. And then some of the advantages and disadvantages. A single responsibility principle. You can separate the interface or data conversion code from the primary business logic of the program. You have an open-close principle. Here you can introduce new types of adapters into the program without breaking the existing client code as long as they work with the adapters through the client interface. Overall, the complexity of the code increases because you need to introduce a set of new interface and classes. Sometimes it's simpler just to change the service class so that it matches the rest of your code. And this is the end of our presentation. Thank you.
Thank you.